Okay, y'all, yesterday we talked about discontinuities, and there were 3 kinds. What were the 3 kinds? Jump, infinite, and removable. Okay, so jump, infinite, and removable. And when we talked about the discontinuity, we talked about with the vertical asymptotes. So this is the x equals, right? This is what we talked about yesterday. This is not on your notes for today, okay? No. This was yesterday's notes. Yesterday's. So then we talked about the end behavior. And do we care about what's in the middle of a graph on the end behavior? No. We're just looking at the end behavior. And when we look at these, we look at the asymptotes that go this way. So these are our horizontal asymptotes for end behavior. And if I was going to do end behavior, what do you write? X approaches infinity as f of x approaches, and what's it approaching here? 0. And then you do as x approaches negative infinity, right? Okay, so here's what we're going to talk about today. Today we're going to talk about symmetry. So we have 2 types of symmetry. I have line symmetry and point symmetry. Line symmetry and point symmetry. So line symmetry, if you look at this graph right here, it's symmetric around the x-axis, correct? That means if I folded it in half over the x-axis, this and this would both touch. So if I have this point, I also have this point, right? They touch. And the x doesn't change. The x is the same, but what value changed here? The y changes, right? This is a reflection over the x-axis. So if this is a reflection over the x-axis, this is a reflection over the y-axis. And if it's a reflection over the y-axis, this point and this point, the y doesn't change, but what did change? The x changes this time. So, where it says the graph can be folded, okay, so that's true, right? We can fold it, but what you're actually saying is when it's reflected across. So when it's reflected across the x-axis or reflected across the y-axis. So this one is point symmetry. The last one is point symmetry. And what this says is the graph remains unchanged when rotated 180 degrees around a point. Y'all, that's a lot of fancy words for if you take your paper and you turn it upside down, it's the exact same graph. Okay, that's 180 degrees. Okay? So this is the cubic, and if I rotate it 180 degrees, I get the exact same graph. So it's symmetric around the origin. All right, so we reflect over the x and y axis a lot, and a lot of times, Cabello, we rotate around the origin. So this this was reflected over the x-axis. The x remained the same, but what changed in that one? The y's. So I also need x and negative y. So we're going to replace my y with a negative y if it's symmetric, if it is reflected over the x-axis. So if we do the y, and the origin, we do both. Mrs. Archer. Hey. I know. And when I saw it was you, I knew you were going to ask too, so I started pulling up my Skyward. Well, the part of the problem is they used my Skyward as the demonstration one, so nothing looks the way it's supposed to look. I have none. I have not a single grade in there right now. I know. I can't be. Okay. Oh my gosh. Yeah, you should have. Okay, it's Jesus Gonzalez, and it's with a Z, and his ID is 0306635. And he told me he had first semester with Gonzalez and failed, and then he went down to Ferris, and he said he failed there. But I don't know if that's true or not. But all I know is he's drowning. Good luck. Thanks. Okay. So look at number 1. Look at number 1. Okay, Cavello, I am talking again. I'm not asking again. Yeah, I'm not. Is it symmetric around the x-axis or the y-axis? Or if I turn it upside down, it would be the same graph. Okay, who just said it would be the same graph? Was that you, Joseph? Look, take your paper and turn it upside down. These are pointed up. If you turn it upside down, way are they pointed now? So it's not the same graph. If I fold this in half, will they touch? So this is around the y-axis. So if I'm testing for the y-axis, what am I going to replace? X with a negative x. So wherever I see an x, I'm going to put a negative x. So what is negative x to the 4th power? Positive x to the what? 4th power. Why would it be the 2nd power? I don't know either. It's to the 4th power. And then minus x squared would become positive x squared, right? Negative times a negative is a positive. So, does this match this? If it matches, then it is symmetric around the y-axis. Okay, so if I fold this in half this way, would this touch this? so it's not around the y-axis. If I fold this down, would it touch? No, so that's not x-axis. If I rotate this 180 degrees, it is the same. So this is origin. If it's the origin, I have to replace the x and the y. Okay. So at the origin, we have to change both of them, x and y. So where I see the x, I'm going to put a negative x. Where I see the y, I'm going to put a negative y. So this time, what's a negative times a negative? Positive. So do I end up with the same thing? I do. So that's okay. Okay, this one. Can I fold this in half with the y? Nope, because there's nothing over here. Can I fold it this way? Yes. Okay, so with the x, what do I have to replace? So in here, I'm going to have 4 and what's negative y times negative y? So I get 4 it matches, so check. I'm going to go down and do number 5 next. So the x-axis, if I fold this down, this would come down here. Would it touch over here? No, so it's not the x-axis. If I fold this over here, would it touch? So it's not the y-axis, right? So if I turn this upside down, is it the same? Is it? What happens to this part? It's not on the right side, is it? So it's none of them. So what about, so look, so all my other class, the reason I'm stuttering is because every single other class I've taught so far, they've all stopped me and be like, how come that's not origin? And you're all just sitting there. So I'm like, all right, whatever, I'll just go on. So look, so right here, if you take this and you rotate it 180 degrees, this comes over here, and now this part is over here. So it's not the same. Okay? 180. Okay? So do you see now? You see why now? Okay. So that's the same. Nobody asked here either. Exact same thing. If I turn this 180 degrees, this is now on this side, so it's not the same graph. Okay? So that's how you tell. Like, literally, you turn your paper 180 degrees and look. If it changes sides, it's not the same graph. But this one, when we did this, when I rotate this, this is now down here and this is up here. Exact same graph. Okay? Okay, so what about this one? Can I fold this in half? Yes. So that's the y-axis. Can I fold this down and they touch? So that's the x. If you turn it upside down, is it the same? So it's all 3. So the x-axis, I change the y. So that checks. If I change the x, so that one checks. And if I change both of them, I still get y squared minus x squared equals 1. And that checks. So all three of them checked. So the next one. Can I fold it in half up and down? So that's not the x, right? If I rotate it 180 degrees, this is up here now, right? So it's not the same graph. Can I fold it in half this way? So that's the y-axis. So which one do I have to change for the y? So what does an absolute value do to a negative number? So do these match?